It's quite an honor and privilege to introduce someone you've followed for years and whom you've actually idolized. Yeah. I'm from Manila, and from where I come from, back in the days, I'm talking of the 90s, books that Foyle's bookstore in London calls the Know-It-All. We were in London a couple of weeks ago, and we were at Foyle's bookstore, and Foyle's bookstore has this very interesting way of classifying books. So if you want to go to a history section, you go to A Matter of Time. If you want to know art, there's this artsy-fartsy section. And then there's this big pile of books that says the Know-It-All. And that's where you'll find books like Yuval Harari's Sapiens, Nicholas Christakis' Blueprint, Jared Diamond, and then, of course, the book that you have on your table. The Know-It-All books are hard to come by in the Philippines back in 1990s. So you could imagine my joy when I walked into a small bookstore. This was 1994, 1995, and I saw this book that says, with the title, Why Zebras Don't Get Ulcers. Yeah? And somebody was holding it, and I was beside it, and I was using all my mental powers to say, put down the book, put down the book. And he did that, and I grabbed the book, and I had a wonderful afternoon reading all about stress and how stress affects us and now become vulnerable. The second book was easier to get because I happened to be in the US. It's Testosterone, The Trouble with Testosterone, which begins with the chapter, How Big is Yours? It's not about that. It's about this thing called interstitial nuclei and so forth. We happened to be in London when the third book came out, the Memoir of Primates. And I brought it to the train with me, and that's where I would read it. And Rodora, my wife, would nudge me every now and then to say, you're doing it again. I said, doing what? You're smiling to yourself, and your lips are moving, and the people are looking at you, and so forth. That's how engaging that was. And then finally, the book that you have on your table. What engaged me about the book so much is to ask this very bold question of, what is the biology of who we are, our individuality, our limits and potential? And as society is asking questions about nurture and nature, and then these things about biology and limits are coming out, what are we actually responsible for? And what, in effect, some excuses that we can make. Anyway, the book on the table is as magisterial and as encyclopedic as you can come across about biology and behavior and the neurosciences. So I'll dispense with the usual as professor of biology and neurology and all of that, and his grantee of MacArthur's Foundation Genius Grant. So here's the real deal, not like the fellow who boasts of being a stable genius. So, ladies and gentlemen, prepare to be engaged, enlightened, and educated. Professor Sapolsky.
Well, thank you, Jojo. That was an embarrassing introduction, but thank you. Thank you also, Michelle, for getting me here. I'm sure all of you know not only Michelle, but how wonderful she is. But my wife and I have been friends with Michelle and family since our kids were both about a month old. So this is a very nice setting to be in. Let's see, starting off, just to put us in context here, if you're a biologist, if you're interested in biology at all, as I am, and you sort of spend enough time thinking about us humans, after a while you begin to wonder, Are we just a collection of neurons? Are we just a collection of cells, of molecules? Are we just another primate, as shown here? And when you try to make sense of us, we humans, as biological organisms, as socially behaving biological ones, there's this huge, endless challenge, which is our human capacity for extreme. We're the most miserably violent species on Earth. We do stuff that no chimp could ever dream of doing. I mean, just like any chimp out there, we can take something heavy and smash in somebody's skull, but we could be violent by doing nothing more energetically taxing than pulling a trigger, or looking the other way, or signing an order, or pretending you didn't hear, or damning with faint praise, or being passive-aggressive. We're extraordinarily gifted and varied in our ways in which we're miserable to each other. So that would be pretty easy to deal with. But the thing that complicates it is, at the same time, we're the most wildly altruistic species on Earth. We do things no other social species would ever dream of in terms of that. We're more competitive than any other species, but we're more cooperative, we're more compassionate, we're more brutal. How do we make sense of us and make sense of the biology of us as humans, our worst and our best moments? Because each is more extreme than you will find in any other species out there. How do you understand the biology of this? Now, one thing that's clear is, if all you want to understand is the biology of, like, the behavior you've just done, that's stupidly, boringly simple. Your brain says something to your spinal cord, and your spinal cord says something to your muscles, and hooray, you've behaved. What's challenging is understanding the meaning of the behavior. Because the thing about us is, we do the exact same thing with our muscles, we carry out the exact same primate behavior, and depending on the context, it could be horrendous or it could be wonderful. Pulling a trigger, and that could be an appallingly damaging act, or if you're pulling that trigger, suicidally drawing fire on yourself away from innocent people, that's as wondrous as we can be. You sign something giving a large amount of money to a deserving charity, that's us at our most wondrous. You sign an annual report where you lie through your teeth about what your company did that year. It's all context, over and over. The challenge is not to understand our behaviors, it's to understand the biology of how the same exact behavior means such a different thing in such a different context. And this is hard. This is hard biology. And when you look at it, one of the things that's clear is you're going to get nowhere if you've decided, aha, here is the part of the brain that explains everything. Here is the brain chemical. Here is the hormone, the gene, the childhood experience. If you do that, you are never going to get a picture of what's going on. Instead, you got to go through a whole strategy here. Somebody does something. They pull a trigger, they sign a form, whatever, and it's a wondrous act, it's an appalling act, it's ambiguously in between. And we ask this profound human question, why did that person just do that? Why did they pull that trigger? Why did they decide to sign that paper that had a wondrous outcome, a horrendous outcome? And when you're asking that, you're actually asking a whole cascade of questions. What went on in that person's brain 1 second ago that caused them to pull that trigger, to sign that order, whatever it is? But you're also asking, what went on in the seconds to minutes before? What sensory stuff in the world around that individual triggered those brain cells to do that? But you're also asking, what was going on in the hours to days before? Hormone levels, what did they have to do with how sensitive the brain was going to be? And then you're off and running back to neural plasticity over the previous months, back to adolescence, childhood, fetal life, because it turns out what your fetal environment was has an amazing amount to do with what sort of adult brain you've got at this point and what sort of decisions you make. But then you've got to push even further back. Forget when you were fetus. How about when you were nothing more than a fertilized egg made up of your genes? What do genes have to do with it? And then, amazingly, you got to push even further back. What kind of culture were your ancestors inventing 500 years ago? What sort of ecosystems brought that about? Because that will have had something to do with what your life was like from your first minute of birth, and finally all the way back to what does evolution have to do with what kind of species we are and how we react in these sorts of circumstances. Okay, so starting with this sort of thing, we have one of these wonderful, horrible in-between behaviors. And we ask our first version of the why did that behavior occur question, what went on a second before in that person's brain? Now, if we're talking about humans at their worst, where we have to start off with is a brain region called the amygdala. The amygdala is about violence. It's about aggression. Take a human, take a monkey, take a rat, and stimulate the amygdala, and you will get unprovoked aggression, surgically destroy the amygdala. You can't evoke any aggression anymore. The amygdala is about aggression. But amazingly, get some amygdalologist and sit them down and ask them what the amygdala is about, and the first thing they're going to say is not aggression. They're going to say fear. The amygdala is fear. The amygdala is where you store the fears you didn't have to learn, those phobias, those implicit sort of instinctual memories that you have about what's scary. But the amygdala, even more importantly, is where you learn what stuff to be afraid of and who to be afraid of. In other words, you can't make any sense of the biology of us being violent outside the context of us being afraid. And in a world in which no amygdaloid neuron need be afraid, we'd all be lying down between lions and lambs much more often. Now, the whole thing about the amygdala processing fear is something very interesting goes on. Okay, so you're walking along and you see something scary. What's going on in your brain? Rattlesnake, the information goes from your eyes into a switch way station, transfer point in your brain that sends it to your visual cortex. And then your visual cortex starts a science fair project. The first layer of neurons there do something or other, and they turn what you just saw into a bunch of pixels. And when they're done, they hand it to the second layer, which turns the pixels into lines. And then they go to the third layer, which turns the lines into dimensionality. And umpteen layers later, your cortex says, oh my God, it's a rattlesnake. Maybe we should tell the amygdala about it. You're long dead by then. That takes about a half second. That's glacial in your brain. Turns out something much more interesting is occurring as well. That visual information comes in, and at that first way station, visual, auditory, all the sensors coming in there, they take a shortcut straight into your amygdala. Your amygdala gets that information in under 1/10 of a second. In other words, your amygdala knows it's something scary while your visual cortex is still futzing with the instruction manuals. What you got then is your amygdala can know it before you consciously know it. It does it in under 1/10 of a second. That's about 4/10 of a jump on your conscious awareness. That's wonderful. That gives you almost a half-second lead on jumping out of the way of something scary, but there's a downside. Which is, it turns out there's a good reason why you got this complicated visual cortex doing all this feature extraction processing. It's to get an accurate answer as to what it is you're looking at. The amygdala gets it incredibly quickly, but it's a not terribly accurate conclusion as to what you're looking at. And depending on who the person is you're looking at, in what circumstances, and what implicit biases you bring to it, you've decided that cell phone they're holding is actually a handgun, and you pull the trigger. And we all know the world in which that has sort of dominated the news. Thus, amygdala is teaching us neurobiology of fear, neurobiology of violence are completely intertwined, and the amygdala is poised to get all sorts of privileged information, but not very accurately, and disasters ensue. Okay, next brain region that's interesting, something called the insular cortex. In fact, it's totally boring in most animals out there. Here's what it does in a rat. A rat bites into a piece of food. The food happens to be spoiled, it's rancid, it's toxic, it's disgusting, and in about 1/10 of a second, the insula activates. What does it do? It triggers all these reflexes. The rat spits out the food, it gags, maybe it throws up. What does the insula do? It keeps you from poisoning yourself on rotten food. It detects gustatory disgust. So it does that in us as well. Get some, I don't know, college freshmen getting their Psych 101 credit and stick them in a brain scanner and give them some fetid, rancid, disgusting thing to bite into, and in a tenth of a second, their insula is going to activate. But now do something a little more subtle. Don't give them a disgusting food to bite into. Just make them think about a disgusting food. Think about its little legs pushing against your lips as you try to force it down. And you're going to activate your insular cortex. Because in us, we can activate it not just for gustatory disgust, we can do it when we just imagine gustatory disgust. But we can do something even more amazing than that. Now stick that person in the brain scanner. Don't give them a disgusting food. Don't make them think about a disgusting food. Make them think about something else disgusting. Something like that. And in most of us, the insular cortex will activate. In us, it also does moral disgust. And that teaches us something interesting about the evolution of the brain. Insular cortex is about 70 million years old, and it's been, 30,000 years or so that humans have come up with norm violations that could be so extreme that we call them moral impurities or what. And what happened then, there was a committee meeting, and they sat there and they said, well, we can't invent a new part of the brain. What are we going to do with this new morality stuff we've just invented? Somebody says, oh, insular cortex, it does disgusting food, that's kind of like disgusting behavior. I know. Okay, give me some duct tape, push it in there, and now suddenly moral disgust is in the insula's portfolio. For a neuron there, it cannot tell the difference between a disgusting food and a disgusting moral act. And that's why, if something is morally disturbing enough, we feel sick to our stomachs. We want to puke. We have a bad taste in our mouth. Now that could be wonderful, that could be great, because a lot of the time if you want to right a wrong, this is not some abstract intellectual problem. You need a visceral fire in your belly to go after it. This is where the viscera come from. However, there's a downside, which is one person's moral disgust is somebody else's perfectly normal, loving lifestyle. Moral disgust is a moving target. And you are really inviting trouble if you decide your litmus test for what counts as right or wrong around you is if it feels viscerally disgusting. If it makes you puke, you must rebuke. If you do that, all you're doing is setting yourself up for deciding that when they do something different, it's so different that it feels disgusting, and that's your cue that it's wrong, wrong, wrong. All you're doing when you do that is set yourself up for having a litmus test what your stomach has to do with moral issues philosophers have spent millennia thinking about. It's dangerous. So what we see with the insula is, in us, it doesn't just do sensory disgust, it does moral disgust, but moral disgust is a moving target, it's context dependent, all of that. And what do you know when the insula activates because of something morally disgusting? What's the first part of the brain it talks to? The amygdala, a fraction of a second later. Okay, switching gears now. Another part of the brain, frontal cortex. It is the coolest part of the brain, and I wasted 30 years of my life in my lab studying the wrong brain region instead of the frontal cortex, and I regretted deeply. Frontal cortex, we've got more of it than any other species out there. It's the most recently evolved part of the brain. What does the frontal cortex do? It makes you do the harder thing when that's the right thing to do. Gratification postponement, long-term planning, emotional regulation, impulse control. If you're sitting there being tempted to do something and you're managing not to, it's because your frontal cortex is working to keep you from doing the impulsive thing at that point. Now, when you think about the frontal cortex, you get this very easy picture about its relations with something like, say, the amygdala, which is the frontal cortex sends this big, huge cable down to the amygdala, which inhibits the amygdala. What the frontal cortex does is race down to the amygdala as fast as possible to stop the amygdala before it does something totally impulsive and dumbass. What the frontal cortex does is it shows up and says, ooh, I wouldn't do that if I were you. You're going to regret it. It's like the entire relationship between the frontal cortex and the amygdala consists of the former showing up and preaching Christian temperance and things like that. Okay, that's the easy picture of what's going on. But it turns out, when you look at the structure of the brain, okay, in any case, what you begin to find is there's this amazing thing going on. Yeah, the frontal cortex sends all these cables down to the amygdala. Turns out the amygdala sends just as many back in the other direction. Okay, and thus, thank you, what you get is the amygdala sometimes can dominate the frontal cortex instead of the other way around. Now, as soon as the amygdala has a voice in the matter, it can have some pretty strange taste as to what counts as the right thing to do. And think about it. Every single thing here takes a frontal cortex working hard. These are all circumstances where it is taking that sort of self-discipline. Think about it. Okay, you're in a circumstance where you are being tempted to lie for personal gain, and you're trying to resist. Your frontal cortex is going to be working hard. But then you decide, the hell with it, I am going to lie. And at that point, your frontal cortex works really hard to make sure you do a good job at lying, to make sure you remember to make the right amount of eye contact and keep your voice from cracking and remember what you're lying about so you don't contradict yourself later. If you have a part of the brain that is both central to sort of resisting temptation and then doing a good job at wallowing in the temptation when you give into it, this is a very complex brain region. So what we see here is frontal cortex makes you do the harder thing when it's the right thing to do, but that is a value-free thing as to what counts as the right thing. And what this also shows you is we've got this very self-congratulatory view that we in our gigantic frontal cortexes are these gleaming computers of rationality in our decision-making, and instead what you see is the frontal cortex is marinating in all that emotive yuck coming up from down below. The notion of us as purely rational beings is way overrated. Okay, an additional brain region having to do with a neurotransmitter, a chemical messenger in the brain that I suspect lots of us have heard of, called dopamine. Dopamine jargon, dopamine in the mesolimbic and mesocortical dopamine system. What is dopamine about? It's about pleasure. Everyone knows this. Cocaine works on the dopamine system to release it here. Take somebody, a human, a monkey, a rat, and give them an unexpected reward, and as shown here, the dopamine system roars into action. It's about pleasure. It's about reward. Turns out, it's not at all. Now take that human or monkey or rat and put them in this situation. A little warning light, a little signal comes on, a light comes on in the room, and what that means is now if you press a lever 10 times, you get a reward. Signal, work, reward. Learn this, totally straightforward. So now, when does dopamine go up? Does it happen when you get the reward? Not at all. It goes up once the signal goes on. What's that about? That's you sitting there saying, whoa, this is going to be great. This is going to be fantastic. It's not about reward. It's about the anticipation of reward. And remarkably, if you block that rise of dopamine, you don't get lever pressing. It's also giving you the motivation, the goal-directed behavior to do this. Okay, so this is a circumstance where you press the lever 10 times, you get the reward. Totally predictable, the world is making sense. Now switch things to, you do the work and you get the reward only half the time. Unpredictably, what happens to dopamine? As soon as that little light goes on, dopamine goes through the roof. What have we just done? We've introduced a word into our brain chemistry, the word maybe. And nothing fuels that lever pressing like the word maybe. And we just pound away at it because, today I'm feeling totally alert and awake, but I'm such a loser. But today I'm going to get this lever pressing perfectly, but I'm going to mess up again because I always do. But I got my lucky socks and teetering there on that fulcrum. This is the principle understood by the neuroscientists who invented Las Vegas. Intermittency, uncertainty, unpredictability, and it just cranks out the lever pressing like mad. So what we see here is, most of all, rather than being about reward, dopamine is about the goal-directed behaviors. It's not about the pursuit of happiness, it's about the happiness from the pursuit. But what we see here is, it is a very, very vulnerable system to ambiguity and uncertainty and maybe. And once you get that going, it is a system that goes full blast. Okay, couple of other brain regions, briefly. area called the fusiform cortex. It's a primate specialty. It recognizes faces. That's great. Another area called the anterior cingulate. What does it do? It does empathy. Poke your finger with a pin, the anterior cingulate activates. Watch your loved one's finger poked with a pin. It does the same thing. It feels your pain and it feels someone else's pain. So that's great, except both of these areas come with fine print. Fusiform. Take somebody in a brain scanner and flash up faces, one every half second or so, and each time the fusiform activates, and take your average person in the brain scanner and flash up the face of somebody of a different race, and the fusiform doesn't activate as much. And you don't process the face as a face as much, and you don't remember it as accurately. Look at a film clip of somebody's hand being poked with a needle, and the anterior cingulate activates. But if that hand has different skin color from your own in the average person, it doesn't activate as much. In other words, it depends. Whose face, whose brain, whose pain. Okay, so this brings us back to sort of what's going on in that brain 1 second before you've made that decision to pull the trigger, to sign the order one way or the other. Now, however, no brain is an island, and what we now have to ask is, what was going on in that sensory world in seconds to minutes before that triggered the amygdala to do this or the frontal cortex to do that? What does sensation going on there have to do with those decisions you make? Now, some of this is obvious. If somebody is running at you with a knife, screaming and frothing, you're going to activate your amygdala. But much of the time, what's interesting here is sensory information is coming in and affecting our behavior, and we haven't a clue it's happening. Let me give you a tour of some examples of this. In the center, pair of eyes. Put up a poster with a pair of eyes like that on a bus stop, and people litter less. Flash up those eyes on a computer screen, and people cheat less on an online game. Flash the eyes up for 1/10 of a second. You barely even know what you saw, and you have that effect. Just this subliminal sense of being monitored. Or on the far left, get somebody, volunteer to take a swig of something disgusting like cod liver oil, and up to 10 minutes afterward, the person will recommend more severe punishment for someone's norm violation. Because you got a bad taste in your mouth, and that must be why. Next version, on the bottom, sit somebody down in a chair, either a nice, comfy sofa or a hard wooden chair. Give them a bunch of resumes to read where they have to evaluate these people afterward. And it turns out, if you're sitting in a hard wooden chair, you're more likely to rate somebody as having a hard, inflexible personality. Can you believe how you're sitting in a hard chair and you decide people are hard asses as a result? This is totally crazy. Well documented. Okay, shifting further to the right, I love this study. Take somebody and have them fill out a questionnaire about their political views. Social politics, geopolitical, economic, whatever. And if you're sitting in a room with smelly garbage, people become more socially conservative. It does nothing to your economic views, nothing to your geopolitical. What are you doing subliminally? You're sitting there saying, something's disgusting, something. They are what's disgusting. It's wrong, wrong, wrong when they do that, just from a subliminal smell in a room. Pushing further up, top right there, this was a study in a very prestigious journal a few years ago, which should bring some aspects of our society to a standstill. This was a study of all of the parole board judges in a particular country where it was studied, all of the parole decisions they made over the course of a year. And it was more than 5,000 of them. Does this person walk free? Does this person go back to jail? And they looked for every possible predictor as to when the judge would make the decision they did. And the single best predictor was how many hours it had been since the judge had eaten a meal. Appear before the judge right after they've eaten, 60% chance of parole. 3 hours later, 0% chance. What's amazing about this is we know how this works. Blood sugar levels. What's the most expensive part of your body? Your brain. What's the most expensive part of your brain? Your frontal cortex. And when your blood sugar levels are low, the frontal cortex has that difficulty doing that really tough thing of looking at the world from somebody else's perspective and thinking about what things they went through that you could never dream of. What's also amazing is you sit down one of those judges right after they've made a decision, and you say, whoa, that's interesting. You sent this person back to jail, but back earlier you let that person go free. How come you made that decision? They're not going to talk about blood sugar. They're going to talk about freshman philosophy class and Nietzsche or something or other, and all along it's this sensory regulation going on there. Another example, top, middle, somebody is playing some online game. The darker the computer screen is, the more likely people are to cheat. Even your computer screen can't see you being a jerk as readily if it's dark there. Subliminal. Then top, far left, this is the most depressing finding in this whole field. Okay. So take people, put them in that brain scanner again, and you're flashing up pictures of faces, like 1/10 of a second, a little bit more than that. And in your average subject, flash up a face of a different race, and the amygdala activates in 70 thousandths of a second. Damn, this is depressing. We are hardwired for racism. This is inevitable. This is in the very core of our brains, not for a second. Now do the study a little bit differently. Now I read up recently and I discovered San Francisco apparently has a baseball team, and they have some other team somewhere down south that they have some rivalry with. Now take somebody who's a fanatic Giants fan, stick him in the brain scanner and flash up faces, and now each face is either wearing a Giants cap or a Dodgers cap. And your amygdala could care less what skin color that person has. All they're doing is tracking the caps and activating when it's a Dodgers cap. Inevitability of racism, my ass. Baseball has been around, I don't know, 1,000 years or so? And it's instantly replacing supposedly inevitable categories. This tells you something about who is an us and who is a them could change in a fraction of a second. Okay. So we see we're constantly being influenced by sensory information like this, and what's most interesting is most of the time we haven't a clue it's there and what it's doing. Okay, now pushing further back, our wonderful act, our awful one in between, and now we're asking what went on in the hours to days before that influenced your brain to be more or less sensitive to whatever. What did hormone levels this morning have to do with your decision whether or not to pull that trigger or assign that report? Now, if we're talking about humans at their worst and hormones, where we got to start off right off the bat is with testosterone. What's the deal with testosterone? Why is it that in almost every species out there and in every culture, males are such pains in the rear? It's because testosterone causes aggression. Turns out, testosterone doesn't cause aggression. It does something much more interesting. Take 5 male monkeys, put them together, and they form a dominance hierarchy. The first one dominates 2 through 5. The second dominates 3 through 5. Nice, stable hierarchy. Now take the one who's ranked in the middle there, the third ranking one, and shoot him up with testosterone. Give him like so much testosterone that like his amygdala is growing antlers. There's so much there. Is he going to be involved in more fights now? Absolutely. Does this mean now that number 3 in the hierarchy is now going to be challenging number 2 and number 1 and upending the whole Absolutely not. Number 3 never goes anywhere near numbers 2 and 1. What happens is number 3 is a total misery to poor numbers 4 and 5. Testosterone doesn't create aggression, it just increases the volume of the social aggression you've already learned. It just ups the amplitude to it. Now, it turns out it does something even more subtle than that, which is what testosterone mostly does is when your status is being challenged, it makes you do whatever you need to do to hold on to your status. Okay, that's not very exciting. If you're a baboon and you're male and your status is being challenged, the way you hold on to it is you're going to have a fight with somebody. But with humans, we get status in all sorts of interesting ways. Just go to some fancy private school on the night they have their annual auction and look at these semi-inebriated rich guys chest thumping about who can conspicuously be giving the most money to the school. Whoa, no baboon could understand that that's a route to status. There's all sorts of economic games where you get status by making generous offers. And amazingly, give people testosterone and they become more generous when they're playing that game. In other words, take 1,000 Buddhist monks and shoot them up with testosterone, and they're going to run amok seeing who could do the most random acts of kindness. Okay, so shifting now. That would be interesting. So shifting now to another hormone. If we're looking at testosterone that's gotten a bad rap, now we look at the Teflon hormone that's gotten just an amazing reputation for no reason at all, this hormone oxytocin. Oxytocin is wonderful. Everybody, endocrine jargon, oxytocin is the grooviest hormone on earth. It promotes mother-infant bonding. It promotes pair bonding in monogamous species. Give oxytocin to people, they become more trusting, they become more generous, they become more expressive. Give oxytocin to lab rats, they become better listeners to people's problems, things like that. Oxytocin promotes pro-social behavior. Turns out, it depends on who the person is you're interacting with. Wonderful study among a number of them showing this, done a few years ago in the Netherlands. And what the researchers did was make use of one of the classic problems in moral philosophy, the runaway trolley problem. A trolley has broken loose from the brakes, is hurtling down the tracks, is going to hit and kill 5 people. Is it okay for you to push one person onto the track in front of the trolley? They're going to get killed, it will stop the trolley. Is it okay to sacrifice 1 for 5? Utilitarian philosophy, the amazing thing is you get totally different decisions from people depending on how you word it. Okay, so these Dutch researchers got a bunch of student volunteers, and what they did was they gave them the runaway trolley problem. And they did something interesting. They gave a name to the person you were contemplating pushing onto the track. A third of the time, the name was some good old boy Dutch name like Dirk or Peter or something, but the rest of the time, it was from one of the 2 groups that consistently have negative associations in the Netherlands: German names, oh yeah, World War II, and Muslim names. So now you're sitting there, and this volunteer is trying to decide whether to push Dirk onto the track, what about Otto, what about Ahmed, and what you see is you give people oxytocin, and they're much less willing to push poor Dirk or Peter onto the track, but they're jumping out of their seats to do in Wolfgang or, Mahmoud or whatever. It doesn't make us nicer. It makes us nicer to people who are like us. It makes us crappier to thems. It makes people more xenophobic. It makes people cheat more against thems in economic games. Oxytocin doesn't make us nice. It makes us nice to people who already count as us's. So we see here, hormones are constantly influencing what's going on in your brain. In the case of testosterone, the problem isn't that it causes aggression. The problem is that we hand out so damn much status for aggression. That's the real problem. And in oxytocin, this is not a hormone that's a panacea that should be in the water supply. This is a hormone that takes the us-them divide in our brains and makes it even more dramatic. Okay, pushing further back now, our wonderful in-between, wonderful, horrible state, whatever. Now we're asking, what about the weeks to months before? And what we've now entered is one of the trendiest fields in neuroscience, the field of neural plasticity. Your brain changes in response to experience. Parts of your brain get bigger, others will shrink. Neurons grow new connections, they disconnect old ones. The biggest revolution, top left, in neurobiology in the last quarter century, the adult brain will even make new neurons. Neural plasticity, the brain can heal itself. This is totally exciting. Everybody does neuroplasticity work now. So that's great. That's great, but there's some limitations. First off, no degree of neuroplasticity, no number of rounds of 10,000 hours of practice you might do is ever going to make you LeBron James or Yo-Yo Ma. or ever make you walk again if your spine has been severed. For our purposes, though, much more importantly is neuroplasticity is value-free. And sometimes neuroplasticity can make you much better at being Mother Teresa, and sometimes it can make you much more efficient at ethnically cleansing a village. It's a value-free concept. Pushing further back, how about back decades now? What did your adolescence have to do with this decision now whether or not to sign that report? What does that have to do with it? And it turns out all of adolescence could be explained neurobiologically by two things. First thing, by the time you're about 12 years old, your dopamine system is going at adult levels already. Second fact, your frontal cortex is totally useless when you're an adolescent. It doesn't fully mature until you're about 25 years old. It's the last part of the brain to wire up. What have we just explained? This is why juveniles act in juvenile ways, because you got that dopamine motivation and you got zero frontal control. This explains a ton about, I don't know, everyone's freshman roommates or such. What this also means is late adolescence, early adulthood is the last shot you got as to what kind of frontal cortex you're going to have as an adult making that split-second decision. And when you look at what the frontal cortex has to do, this actually makes perfect sense. It makes you do the harder thing when that's the right thing to do, blah, blah, all of that. What counts as the right thing is very tricky because it depends on your culture. Every culture out there has rules about you shouldn't kill people, but if you kill them, we're going to reward you. Sex is wonderful, except don't do that kind. Lying is bad, but if grandma says this, you should lie to her about that. Oh, no genes could teach us how to do that. It takes us 25 years to learn our hypocrisies of our particular cultures, our self-serving rationalizations. That doesn't come easy. It's a quarter century for your frontal cortex to even have a shot at being able to figure out the workings of that. Okay. So what we see here is adolescence is all about dopaminergic maturity and frontal cortical immaturity, and it's the last part of the brain where you are going to have a chance of getting a good compass, a good moral compass, I dare say, as to what would count as the right thing, even if it's harder, and that's why you have delayed maturation there. It takes a long time to figure that out. Okay, how about hurtling back now all the way to childhood? Now, scientists have made an amazing discovery in recent decades, which is they've discovered that childhood matters. Childhood matters for what kind of adult brain you're going to have. And different types of childhoods produce different types of adult brains. And the big question becomes now the nuts and bolts biology of how does childhood experience, different types of experience, how does that change the kind of brain you're going to put together, the kind of frontal cortex you're going to have? How does differential childhood experience, what does that have to do with the adult brain you'll have? And this brings us to the trendiest concept in all of the life sciences these days, this field called epigenetics. Genetics, your DNA sequence. Epigenetics is the regulation of your DNA sequences. And it turns out environment, early experience can turn certain genes on for the rest of your life, can shut some of them off forever after. It's throwing on-off switches in an epigenetic fashion. Let me show you how this might work. Okay, amazingly enough, lab rats, rat mothers, differ as to how good they are at mothering. Okay, what counts as being a good mother rat? You pick up your pup a lot, you lick them a lot, you groom them, you carry them around. This is kids going to the Ivy Leagues. This is attentive rat mothering. Okay, so suppose you have lucked out and you have one of these attentive rat mothers and she's licked and groomed you when you were a pup. What that does is, while you were still that pup, it causes an epigenetic change in one place in your brain. And as a result, when you're an adult, you're going to secrete very low levels of stress hormones. Okay, that turns out to be great for all sorts of aspects of health. There's another thing that happens. So you now have nice low levels of stress hormones, and you're a new mother, And low levels makes you more likely to be one of those attentive mothers. In other words, you pass on this trait to your offspring. It has been shown to go out 6 generations in lab rats. This is not genetics, this is regulation of your genes. And remarkably, this works the same way during your fetal life. Okay, back when you were a fetus, suppose you were exposed to lots of stress hormone levels. Why? Because your mother was stressed by starvation, by refugee status, by abuse at home, who knows what. Elevated stress hormone levels in her bloodstream got into yours, got into your brain. And it causes an epigenetic change in the brain so that as an adult, your amygdala is going to be bigger than normal and more reactive and see threats everywhere, and you're going to have elevated stress hormone levels. So that when you're pregnant, your fetus is going to have the same epigenetic change. Generations of this. So what we see here is early environment sculpts your brain, sculpts your endocrine, your hormonal systems, and what is most amazing is some of these effects could not only be lifelong, they could be multi-generational. Okay. Pushing even further back, forget when you were even a first trimester fetus. How about when you were nothing more than your genes back when you were fertilized? What do genes have to do with our best and worst behaviors? And there's no subject I'm talking about here which is more controversial than this, genes and behavior. Genes and behavior. Why is this? Because we're living in the genomic era. The genomic era. We've sequenced the human genome. Let's see. Oh, thank you, Michelle. Thanks. Right around this point, you get this horrible anxiety that please don't let me get the hiccups from drinking that quickly. Okay, we live in the genomic era. We have sequenced the human genome. You can go about 40 miles south from here to 23andMe and get somebody like a birthday gift certificate to have themselves sequenced. People in the field get all giddy. Genes are the code of codes. They're the holy grail. Genes direct everything going on in your cells, your organs, your body as a whole. Genes have no idea what they're doing. Saying that a gene determines anything is like saying that the recipe in a cookbook determines when you're going to make that cake. All genes are readouts, instructions. What is really interesting is the decision when to read out a particular gene or not. And what makes that decision? The environment. Now, some of the time, environment, top left, could be really local. You are a cell, and you're running out of energy, and what that does is it turns on a gene, and that gene makes more of a thing called a glucose transporter, and now you take up more glucose. You've solved the problem by your cellular environment affecting gene regulation. Or environment in the middle there could be your whole body. You are a muscle cell and you're being soaked in lots of testosterone, and what the testosterone does is it turns on genes that make the muscle cell grow bigger. You put on muscle mass. Or environment in the usual sense, you've just given birth, you pick up your newborn and you smell your child, and you are going to activate genes in your hypothalamus having to do with oxytocin. Oh, genes controlling everything, my ass. This is, you smell your baby's tush and you change gene regulation in your brain. Genes are controlled by environment. Most importantly, the same gene works differently in different sorts of environments. Here's one important example of this. Just look at red in the middle there and like minutia, don't write anything down. There's this gene, everybody in this business loves this gene because it's so interesting. It's called MAO alpha, monoamine oxidase alpha, has something to do with brain chemistry. And it turns out MAO alpha comes in 2 different flavors. And a ton of lab research had shown that if you get this flavor, and you're a monkey or a lab rat or whatever, you're more aggressive than normal. This variant is associated with elevated levels of aggression. So what about humans? Because we have the same two flavors. Massive studies, 17,000 people followed from birth into adulthood, genetic information on them, and what they showed was if you had the bad version of the MAO alpha gene, by the time you were 25, you were significantly more likely to have a history of violence. If, and only if, you were also abused as a child. No childhood abuse, doesn't matter which version you have. It's not the genes, it's the genes and the environment it interacts with. And what we see here is that after a while, it doesn't even make any sense to ask what a gene does, only what it does in a particular environment. Okay, so that's cool and that's interesting, but like in reality, like organisms only live in single environments. You don't find a lot of penguins in the Amazon, but you find us in the Amazon and in the Arctic and in the deserts and in capitalist societies and socialist and monogamous and polygamous. There's no species out there that has constructed more different environments. And thus, by definition, there's no species out there that is freer from its genes than we are. Okay, so this is all the way back to your genes. Amazingly, we got to push even further back now, back to what your ancestors were up to, what sort of cultures they were inventing, because that has something to do with how you were raised. Here's some of the interesting examples in the anthropological literature. If you look at desert-dwelling people, they are more likely than chance to have invented a monotheistic religion. Look at rainforest dwellers, they're more likely than chance to be polytheistic, and a whole bunch of other traits that go along with that. Another interesting finding in the field, you look at humans living in small bands, hunter-gatherer bands, and the religions they invent always involve gods who have no interest whatsoever in what humans are up to. It's only once humans start living in higher density populations, when you start to interact with strangers, that people invent moralizing gods. Gods who are watching, gods who are judging, gods who know if you've been good for goodness sake, all of that. That is a correlate. As soon as humans start having the potential for anonymous interactions with strangers, we come up with a pair of eyes on the poster boards there in the bus stops that are watching us all the time. That is another predictor. Now, in lots of ways, the most interesting contrast in this literature is between what are called collectivist and individualist cultures. Individualist cultures, the United States is the poster child for that. Collectivist, 99% of the research done on that is done with East Asian cultures. So what you see there is you've happened to have been born into a collectivist culture or an individualist culture. You've got a collectivist mother or an individualist mother, and within minutes of birth, that is influencing how you are being raised. Individualist mothers sing to their babies at a higher volume on the average. Collectivist babies go a longer time nursing than individualist ones. At what age are you weaned? At what age do you sleep alone from your mother? How long on the average you cry before you were picked up? Within minutes of birth, the culture your ancestors were working out half a millennia ago are already influencing how that brain is being wired. So what we see here is genes and brains and cultures and environment co-evolve, and it is impossible to make any sense out of who we are outside of crazy things where our ancestors, like pastoralists in northern Scotland, were they polygamous goat herders? Were they, that has something to do with the brain that you wired up as a child. Finally, we got to push one step further back millions of years. What does this have to do with the sort of species we evolved into? How does evolution teach us about our behaviors? Now, it turns out evolutionary biology, the evolution of behavior, is built around three principles. First one, individual selection. You behave not for the good of the species, you behave in order to leave as many copies of your genes as possible in the next generation, to maximize your reproductive success, the selfish gene concept. And this is every species out there. You have individuals trying to maximize their reproductive success, and we're a great example of it. There are currently 16 million humans on Earth who are direct descendants of Genghis Khan, the most reproductively successful alpha male in human history. So we're a great example of that. Next building block. Sometimes, yes, the best way to pass on copies of your genes is to reproduce. Sometimes the best way is to help your relatives do that. A concept of kin selection, because they share genes with you. This dictum, I would lay down my life for 2 brothers or 8 cousins, and this begins to explain why social species are obsessed with kinship, because it determines who you cooperate with and who you fight with. We're amazing at it. We do something with kin selection that no chimp could ever dream of. We invent material culture, and then we hand it to our kids. They inherit it from us, so that one human could be born worth $1 million more than another human when they're born. This is kin selection on steroids. Third building block. Sometimes it makes sense to cooperate with someone, even if they're not your relative, as long as they cooperate back. Reciprocal altruism. And game theorists have been working on this for decades. What are the circumstances that select for reciprocity? And there's all these models that apply to the evolution of cooperation. And this is totally us. This is barter. This is economics. This is the NASDAQ. This is our entire world of being cooperative based on an expectation of reciprocity. So what we see here is everything about our behavior is explained by these classic building blocks of evolution. Until you look closely. Individual selection. We behave to pass on copies of our genes. But then there's humans who are celibate, who choose not to reproduce. You have sects like the Shakers who go extinct because of their celibacy. Kin selection. We have been selected to cooperate more with individuals who share more of our genes. But then you have blended families of kids adopted from all over the planet from different gene pools. Or how about this third one? Reciprocal altruism. We have been selected to be nice to somebody else if we expect reciprocity, and then we go do something that, like mole rats, would not be able to make any sense of. You're in a foreign city, you're at the airport, you're about to leave, you're about to fly out, and you go into the terminal, there's no person there you are seeing you are ever going to see again, and nevertheless, you stop for half a second to hold the door open for someone. And nothing that any social mammal or any game theorist could ever come up with would predict the fact that we do that all the time. So what we see is evolution of behavior has all sorts of rules and all sorts of predictions, and they turn out not to predict things very well by the time you get to smart primates. And by the time it gets to the smartest social primate out there, us, you see us violating it left and right. Okay, so what have we gotten through here? We see one of our behaviors. The person signs the report and lies through their teeth and ruins their, like investors. The person signs something and turns over money to some wonderful charity, whatever. Why did that behavior occur? And what we see here is you've got to take everything into account from 1 second before to 1 million years before. In other words, what have we just accomplished in the last hour? Am I telling you it's complicated? Oh, great. I had to sit here and listen to that. It's complicated, so you better be damn cautious and humble before you think you understand why somebody has done what they've done, especially if it's a behavior you're judging harshly. What this also begins to give us is something that is, I hope, sort of food for thought in the context of a meeting like this. When you're trying to do the harder thing when that's the right thing to do, when we look at all of this biology, what's more important, that we think our way or we feel our way towards the right ethical decision? Because every moral philosopher for centuries has gotten tenure mostly by saying we think our way, we're cognitive rational beings, and more what this last stretch of factoids have been about is showing visceral, emotive, affective biology, mumbling subterranean forces, and that's shaping us in ways we don't even know are there. Okay, So in lots of ways, just winding down here, the single most important thing about all of these factoids I've just dumped on you guys is that all of this stuff can change. All of this stuff can change over time. All of this stuff is not set in stone. Ecosystems can change. Here, set in stone, is a carving of a hippo from the middle of the Sahara. Because millennia ago, the Sahara was lush grasslands, waterways, all of that. Ecosystems can change over millennia. Cultures can change. In the 18th century, the scariest people in all of Europe were the Swedes. They spent the whole century rampaging through Europe there, and around 1815, something happened. The Swedes became the Swedes, and now we got Greta Thunberg and all of that. You want to see what the Swedish military does now? This is what they're up to. This is the Swedish military. They haven't had a war in more than 200 years. Cultures can change. Most importantly, people change. Brains grow new connections, shrivel up other ones. Brains change, people change, behaviors change, and they could change dramatically. This is a man named John Newton, a British theologian who in his old age played a central role in the banning of slavery in the British Empire in the early 1800s. And amazingly, as a young man, John Newton made a living as the captain of a slave ship. And after he retired from sea, because he was getting a little physically taxing, he went to theology school and grew rich investing in the slave trade. And 35 years after he stopped being in the slaving business, 35 years later, something changed. Something changed in him, something that he celebrated in the thing that he is most famous for, a hymn that he wrote called Amazing Grace. People can change over the course of decades. Another example. Here on the left is a man named Zenji Abe, the morning of December 7th, 1941, and he is about to lead a squadron of Japanese bombers in their attack on Pearl Harbor. He was one of the lead pilots. And on the right is Zenji Abe 50 years later to the day, coming to a 50th anniversary ceremony at Pearl Harbor, honoring the elderly survivors there, and the aged Zenji Abe, in broken English, stepped forward and apologized to the men that he had bombed. And many of them became close with him and each other for the rest of their lives. Sometimes it doesn't take decades. One of the most striking events in World War I was the Christmas truce of 1914. First winter of World War I, various heads of states and popes negotiated there was going to be a truce. The afternoon before Christmas Eve, there was going to be a 3-hour truce up and down the trenches of France so that soldiers could come out of the trenches, go into no man's land, and collect their dead. So the hour came, and the shooting stopped, and British and German soldiers came out and collected their dead. And then after a while, the soldiers started helping guys from the other side carry their dead back. And then they started helping them dig graves in the frozen ground. And before you knew it, they were having funerals shared together, and they were praying together. And by evening, they shared Christmas dinner, and they exchanged gifts, and they sang together and prayed. And the next day, up and down the hundreds of miles of the trenches of France, soldiers refused to go back to fighting. They played soccer with each other and didn't keep score. They exchanged weapons. They exchanged medals. They exchanged addresses so they could visit each other after the damn war was over with. And they made agreements on shooting over each other's heads so no one would get hurt. And in some parts of the trenches, this went on for 3 or 4 days until the officers had to show up and threaten to shoot their men to go back to war. Think about this. An entire lifetime of jingoistic, nationalistic crap, an entire military training, and over the course of mere hours, who counted as an us and a them completely changed. And us was us, all of us, stuck in the trenches, and them would be any damn officer who would spout obscenities about God and country and get us killed for their promotion. All it took was a few hours. And sometimes you don't even have to wait that long. In many ways, the single event that turned the American public against the Vietnam War most was the My Lai massacre. 50 years ago, this past spring, My Lai massacre, My Lai, an undefended village in South Vietnam, mostly filled with elderly people and children, and into it went an American brigade that murdered 350 to 500 civilians there. They mutilated bodies. They gang-raped women and girls before killing them. They burned the fields. They killed the livestock. They poisoned the wells. This was appalling because it happened. This was appalling because the US government covered it up for a year and a half. This was appalling because when they were finally forced to admit it occurred, they handed out a 3-year house arrest to the commanding officer, and it's appalling because this was not the only time that happened. On the right is a man named Hugh Thompson. This is the man who stopped the My Lai massacre. Thompson was the pilot of a helicopter gunship. He got word over the radio that they were shooting in this village, My Lai. Oh, American troops must be defending the villagers there against the Viet Cong. Flew over, landed there, got out, and saw American soldiers bayoneting old women, shooting infants in the head. He went to the commanding officer, the officer destined for 3 years of house arrest before he was pardoned, went to him and said, "What are you doing?" And the officer basically told him to screw off and mind his own business. At that point, there was a last surviving group of civilians huddled at one end of the village, and American soldiers coming at them, and in a minute's thought, Hugh Thompson completely changed who was an us and who was a them. He got in his helicopter and he landed it between the civilians and the American troops, and he trained his machine guns on his fellow soldiers and said, "Take one more step and I will mow you down." And what's the most striking thing is, from the best we scientists can tell, looking at the likes of Hugh Thompson or Zenji Abe or John Newton, is they don't have a part of the brain that none of us do. They didn't invent some kind of brain chemical that none of us have evolved. They're just like us. Nothing about their histories predicted that they would be people capable of doing this. They put their neurobiological pants on one leg at a time, just like the rest of us. What this leaves us with here at the end is, I think, an inversion of that totally irritating cliche, those who don't study history are destined to repeat its mistakes. What I think we have here is exactly the opposite. Those who don't study the history of extraordinary human change, those who don't study the science of what circumstances make it more likely to occur, those who don't study that are destined not to be able to repeat moments of magnificence like this. So on that note, good luck with your own best and worst moments, and thank you.